Hello, welcome back. We're doing notes 3C on the forms of energy today. As always, we've got the quick review here at the top with the word bank right here, and then you're going to use those to fill in those blanks. So pause the video, do the quick review, unpause, and come back for the answers. Welcome back. Let's answer the questions. So nuclear fission is the splitting of the nuclei of a large unstable atom into lighter elements, free neutrons, and lots of energy. We have found a way to contain this reaction and store the energy created, called nuclear power. This process is cheaper than burning coal and is usually safer as a rule. However, it produces radioactive waste, which must be stored. And if the reactions are not properly controlled, there can be radiation exposure. Pause that, make sure you got it right. I'm going to move on. So today's notes are about the forms of energy. So we've got to talk about the definition of energy. So energy is the ability to do work. And work is the amount of energy required to move a given mass a distance. So oddly enough, if I was to sit you down with 15 of the hardest quadratic equations ever that you had to solve in your head, and I put your friend next to you lifting kittens, your friend would be doing more work as far as science is concerned, lifting kittens, because he's moving a mass a distance, and that's work. No matter how hard you're thinking, science doesn't consider that to be work. So the person lifting kittens would be doing more work than the person who was solving those quadratic equations. So science is kind of funny when it comes to some of their definitions. So it is the application of energy. So when I apply energy to something, when I apply force to something, that uses energy, and work is the result. So I want you to think about what kinds of work did you have to do to get you where you're sitting right now, whether it's on the couch in front of the computer or wherever you are. What kinds of work had to be done? Right, you had to get up, and that's work. So getting up out of the bed required you to move a mass a distance. Brushing your teeth requires you to move a mass a distance. Walking around the house requires you to move a mass a distance. Getting dressed requires you to move a mass a distance. If you showered this morning or if you bathed last night, both of those require work, etc., etc. We could go on like this for days. So in other words, there is a lot of work to be done, which requires energy. So where does it all come from? So there are two general kinds of energy: potential and kinetic. And this you should remember from way back, 3rd, 4th, 5th grade. Kinetic energy is the energy of motion. So I want you to use this line right here to describe something that has kinetic energy. So you're going to describe something that has motion. Pause the video, think of something. All right. You might have said a ball rolling down a hill, or a skateboard rolling down a ramp, or pedaling a bicycle, or sharpening a pencil, or juggling. Here's a good question for you. Why are you not supposed to run in the halls? Right, exactly. You might get hurt. You might hurt yourself because you're running and then you have to stop suddenly, and because you've got more energy because you're running, you could hurt yourself. Or you can smack into somebody else. And if you were walking, it'd be like, oh, and you might barely bump each other. But if you're running, so much more energy. So why are you not supposed to run in the halls? Put that in your own words. Something about you don't want to get hurt. So the amount of kinetic energy of an object depends on its mass. So how big is it? And its velocity. So it depends on how big it is and how fast is it moving in a direction. The bigger it is, and or the more energy it has, the bigger it is, and or the faster it's moving, the more energy it's going to have. Think about it. Would you rather, if you had a narrow little hallway that you had to stand in the middle of, and there were two men running at you, and one was 350 pounds and one was 100 pounds, and they're running at the same speed, and you're going to get hit by one of them, who are you going to stand in front of? Right, you're going to stand in front of the 100-pound man because he's got less mass, so he's going to be less likely to hurt you. That guy is going to hurt you. All right, why is it that on 81, cars can go 75, but tractor trailers can only go the top speed of 60 or 65 or 55 or whatever? Same thing. The bigger it is and the faster it's moving, the more force it has. Because those tractor trailers are so much bigger, it takes them longer to stop than a smaller car going the same speed. So more kinetic energy would be with that tractor trailer going faster. So they're the same size, but that one going faster has more energy. So the more work that is done to move the object, the more force it has, the faster it travels, and the more kinetic energy it has. Potential energy is energy of position. It's stored energy or energy of position. So think about something that has energy just because of where it's sitting, or it has energy because it's stored inside of its cells. Okay, so again, would hope that you had thought about this on your own. So now to think about it together, something that has potential energy is going to be a battery has potential energy. Food has potential energy because it's stored in the cells. A book on a shelf has potential energy. And I always ask this, does anybody remember Madame Blueberry? If you watched VeggieTales way back in the day when you were little, there was an episode called Madame Blueberry, and she had a tree house. And she was so blue because she didn't own enough things. And so she went to Stuff Mart, and she bought everything that she could, and they started loading it into her tree house. And of course, the tree house got full of things and fell over. And when asked, Phil Vischer, the creator, said he gave her a treehouse because he wanted it to have potential energy. He wanted to put it up there in the tree so it would have potential energy to do something with for the story. So why should you not put the heaviest items on the top shelf? If you've got something really, really heavy, why do you put it on the bottom shelf? Yes, because the shelf might bend, but exactly. You don't want that thing falling on you from way up there. If it falls, you want it to fall just a little way. The amount of potential energy of an object depends on its mass, how big it is, and its height, how far off of the ground it is. So a 500-pound rock that's only an inch off the ground isn't going to have as much energy as a 500-pound rock way up in the air. So our 500-pound boulder 2 feet off the ground is going to be less energy than the 500 pound boulder 200 feet in the air. I wouldn't want the 500-pound boulder to even fall 2 feet onto my foot, but I would probably survive that, and my foot might even be able to be rebuilt. It might only be just squished a little bit. Where if that boulder falls from 200 feet, I'm going to be dead, let alone my foot being injured. So, and then of course this one's easy. A 500-pound boulder versus a 2-pound boulder, you know which one has more potential energy. It's the one that's bigger. The one that's larger has more of an opportunity to cause more of a problem. All right, so here I wanted you to list as many of the forms of energy as you can. I'm not going to give you any answers here because I'm just wanting to activate your prior knowledge and see what you already know. We know that both kinetic and potential energy have a variety of different forms. And we talked about the forms and the two types of energy in either today's journal or yesterday's journal. So hopefully you had an idea of a couple of the forms of energy. All right, so now let's define them. First, we've got mechanical energy. And mechanical energy is the energy associated with the motion or position of an object. So it can be either potential or kinetic. So, for example, when I draw back my bow and arrow, that's potential. But when I let it go, that potential gets converted into kinetic. And they're both mechanical energy. When the water is stored behind the dam, it's potential. When they open the sluice gate and let the water flow through, that potential energy gets converted into kinetic energy. But they're both mechanical. So mechanical energy can be stored energy or it can be moving energy. So water behind a dam pulling back a bow, releasing an arrow. All of those are mechanical energy. Thermal energy is also known as heat energy, and it is energy found in the motion of the particles of a substance. So the faster the particles are moving, the more energy it has. The reason why you have a fever when you're sick is your particles are moving faster because they're fighting whatever it is that's making you sick. So heat is a direct measure of energy. The warmer something is, the more energy the particles have. So if it's the motion of the particles, that can only be kinetic. So thermal energy is kinetic. So an example, anything that gives off heat. What was I going to say? Hair dryer? Let's do hair dryer. That works. There we go. All right. Next up, we've got chemical energy. Now, chemical energy is only going to be potential because it is the energy that is stored in the chemical bonds that hold compounds together. And when those bonds are broken, energy can be released. And that can be in the form of burning it or in a chemical reaction that either absorbs or releases energy, like endo and exothermic reactions. So chemical energy is found in food. It's found in anything that burns. So anything that you burn it to release the energy is chemical energy. And batteries are also chemical energy. All right, pause that or go back if you need it, but I'm going to keep on going. All right, we did that one. All right. Electrical energy is energy created by the movement of electrons. And it's the movement of electrons, so it's going to be potential or kinetic. Kinetic, exactly, because it's the motion of the electrons. When there is no motion, there is no electrical energy. When I turn the switch off to the lights in the room, they stop glowing because the electrons aren't flowing anymore. So the energy isn't there. So it's definitely a kinetic energy. So example of electrical energy is anything that uses electricity. So charging up your cell phone would be a use of electrical energy. All right, nuclear Nuclear energy is the energy stored in the nuclei of atoms. All right, it's the energy stored in the nuclei of atoms. So is that going to be potential or kinetic? Potential, right, because it's stored inside. So fission and fusion are our examples of nuclear energy. And last but not least, electromagnetic energy is the energy of the electromagnetic spectrum, including light and radiant energy. So all radiation type energy is electromagnetic. So a light bulb gives off electromagnetic energy. The sun gives off electromagnetic energy. That's how it travels to us in electromagnetic waves. So the sun is nuclear energy created by fusion, and then it's converted into electromagnetic energy to travel through space. And then a plant absorbs that electromagnetic energy and converts it into chemical energy and stores it in its cells. And then we cut down that plant and eat it, and our body converts that chemical energy into mechanical energy to move and have our heart beat and all that sort of stuff. All right, so the last thing we're going to do, and hopefully you've got your notebook with you if you're doing these notes on the computer, because I want you to draw, and we're going to draw examples of potential and kinetic, and then we're going to draw examples of all the forms of energy. So here we go. First, we've got kinetic and potential, and then we'll do our 6 forms. So we've got chemical, nuclear, electrical, mechanical, electromagnetic, we're going to abbreviate as EM. And which one am I missing? Chemical, nuclear, electrical, mechanical, thermal. Okay, so now I want you to draw a basic something simple to represent each of these things. You do not have to copy my drawings, but you're welcome to. But if you can come up with something else, that's fine too. So for kinetic, I draw a cliff and I draw a boulder, and we know that it's falling due to our little motion lines. For potential, we'll draw the boulder at the top of the at the top of the cliff. Chemical, I want you to draw some things that are food. I like to do a little chicken leg. And I also like to show a battery because batteries are chemical. And then anything that's burned. So oil, all the fossil fuels are chemical. All right, so nuclear is going to be fission. So we're going to throw a neutron at our large atom. And it's going to split up into smaller atoms. And it's going to release energy. For electrical, I'm going to show charging up my phone. So I'm going to draw a little outlet here. And then I'm going to put another one here, but it's going to have something plugged up into it, which is my cell phone. And I'm going to draw that little battery image, and then I'm going to show how it's filling up. Mechanical energies, energy of motion. So anything showing motion here, I think I'll show a juggler. I've never tried that in previous years. That looks like a juggler, right? Sure, you'll give me that. Electromagnetic is going to be light energy. I like to draw a light bulb, but you could draw the sun. or anything that gives off light. And then thermal energy, anything that gives off heat. I like drawing a iron because the first time I ever burned myself really badly was on an iron. So it definitely sticks with me that is hot. Okay, hopefully you've got all of that. If you don't, you can pause the video and go back. Have a lovely day. Make good decisions. Bye.